All right, so last time what we were doing is we were working with this idea of creating a truth table. And this is the last example we did. We talked about the fact that there's only two statements here. Statements are represented by individually different letters. So here we had a P and a Q. And then we created the different columns based on that information and joining them in different ways. And the one that we're on next, and we also talked about right above this, the number of rows in a truth table is dependent, in fact, upon the number of different individual statements. And it has this interesting expression that we've seen once before with subsets, 2 to the n, so that if we had two statements, like we did on this problem, 2 squared would be 4. We have 4 rows in a truth table. So very quickly we're going to see something with 3 statements. And what is 2 cubed? 8. So the next example, we have 3 statements. We have P, Q, and an R. So we will have 8 rows in the truth table. So let me start with the basic diagram of our truth table. The truth table, these are the columns right now that I'm creating, always has columns for each individual letter. So one of our letters is P, one letter is Q, and the other letter is R. So there's always going to be a column for each of those. The next thing we do is we'd use any of the pieces that sort of are missing, or we start inside the parentheses. So in particular, if you look inside of this set of parentheses, we have a P. We already got a column for that. And we've got tilde Q. But I don't have a column for tilde Q. I only have a column for Q, right? So I need to insert another column, and that inserted column will be tilde Q. And once I have tilde Q, and I have the P that I originally already had as my first column, those two I can now join together because the inside the parenthesis says I'm going to join them together with this symbol that's got this sort of arrow upward. And what was that symbol? It's and. Good. So we've got and tilde Q. So that's everything inside of the parentheses, just like in algebra, right? We do what's in the parentheses first. And then I'm moving outwards. We're going to join it with the R and the V at the beginning, and the V means or. So I have R, or, P, and tilde Q. It's a good thing I don't have any more columns because I'm out of space. Okay, so the number of columns is dependent upon the expression you're given. But the number of rows, which I'm just about to start, is always going to be 8 when I have 3 statements, because that's 2 cubed. Yes, Mark?
What was the 2 cubed about again?
The rows, which I'm about to start. I haven't done the rows yet.
Okay.
The number of rows. So rows go horizontally, right, and columns are up and down. So we're going to look at the rows next.
Right.
All right, so one option is if I have 3 statements, all 3 of them could be true. Right? That is literally one option that could happen. Another option is that I could have the first 2 statements true and the last one false. That could happen. A third option is that I could have the first one true and the second one false and the last one true. Or I could have the first one true and the last 2 both false. So I'm just organizing this in a way that catches all the options. So going down, after that, okay, well, I've explored every possibility of having P true, right? I've got all the possibilities there. So that means everything else has to be the options of P being false. So if P is false, well, I still could have both the other statements true. Yes, Nicole?
So this isn't going with the directions on the last page?
What the directions on the last page say?
P is a false statement.
I think that you're looking at the wrong set of directions. The directions you're looking at are up on example 3, but we are looking at the directions.
Okay, that's the first page. I skipped the page.
Oh, okay, so you're okay now?
Yeah.
Okay, good deal. Yeah, we're looking at the directions that just say construct a truth table, which I probably should have started by saying that was our goal. No, you're okay. All right, so we have the option of being false P statement and true on both the other 2 statements. I could have this false and the middle one true and the last one false. The next option is that I could have the first one false and the second one false and the last one true. And I'm missing one more. All false. Now, I'm trying to describe to you why this captures all of the options. Okay? These are all of my options. Now that you know that this captures all the options, look at the pattern that you see here. What's underneath P? 4 trues, 4 falses. What's underneath Q? True, true, false, false, true, true, false, false. And what's underneath R? True, false, all the way down. That's always going to be the pattern. Okay? So you don't have to go through and think about all the options, right? You can just remember the pattern if you're dealing with a 3-statement truth table from now on. I'm going to go 4 true, 4 false, 2 true, 2 false, 2 true, 2 false, and then I'm going to alternate true, false down. And then I'm done. So these are the 3 columns that will always be there. Again, if you can do nothing else, you can do these 3 columns because they're always the same. Always. Now tilde Q requires me to do something that I haven't done so far, right? It requires me to take a look at the Q column and do what? Negate it. That's what that tilde means, is a negation. So I go back to my Q column and I want to do exactly the opposite of what the Q column said, which means what will tilde Q's column look like?
False, false, true,
So false, false, true, true, and then another set of those, right? False, false, true, true. Let me pause and make mention of the fact here, since we'd mentioned it before. I didn't write that fast, did I? It just shows up there. It's crazy. How many rows do I have?
8.
8, which is what I was supposed to have, right? That's good. So we've got all my rows, okay. All right, so what we're going to do next is we're going to take the P column, which is at the beginning. We're going to take our tilde Q column, which we just created, and we're going to use those in a comparison way. We're going to compare them with the word and, right? We're going to join them with the word and. And when is an and statement true? When they are both true. So if there's any false in either statement, then the result is false. So we're going to go across on the first one. It says true in P and tilde Q has false, so this statement is false. P is true, tilde Q is false, so that's the same thing, right? So I got another false. Now, on the third row, P is true, and tilde Q is true, which means this statement is true. And same thing for the fourth row. It's exactly the same. It's also true. The last 4 rows are already false, and how do I know it without doing any looking much further?
Because all the P's are
Because all the P's are false at the end. So I get these almost for free. They're all false because P is false, and I'm doing an and statement. Okay. All right, so we're going to compare 2 others now, right? We're going to compare the last column I just did, P and tilde Q. And we're going to compare that with row R. So I'm now doing the orangish ones that I've just highlighted, just to sort of draw your attention to which ones I'm looking at. And we're doing an OR statement. So when do you have true on an OR statement? Yes, so if we've got true at all, it's true. Okay, so my first row says true underneath R and false underneath P and tilde Q. That's true. My second row says false and false, which would then be false. My third row shows true and true, which is true. My fourth row shows false and true, which is true, yes. My fifth row shows true and false, which is true. My sixth row shows false and false, which is false. My seventh row shows true and false, which is true, thank you. And then my last row shows false and false, which is false. It's really important that you do them in the right order, because if you go to check the back of the book always does them in this order. So what do I mean by that? Well, I mean, don't switch where P, Q, and R are. Right? P comes first, Q comes next, R comes last. Okay, so that's one thing. Don't change the fact that we've got 4 trues and then 4 falses. Don't flip the diagram upside down, or it's not going to match when you're looking for the answer and seeing if you matched it up right, okay? The book will always do this in the same order. 4 trues, 4 false, 2 trues, and alternating, then false, true, falses, and alternating, okay? That way, if you're looking in the back of the book, what it will do is it shows you the final column's answer. So you can check to make sure that the final column in the back says TF, TTT, FTF. And if it does, then you've got the right final column. That's what you're going to see in the back of the book. They're not going to show you the entire diagram of this. So working backwards and trying to figure out how they got there is really difficult for this. You got to know what you're doing as you're working. Okay, is that all right on this one? Any questions? Okay. The last thing in this section is called De Morgan's Laws. De Morgan's Laws are a way of negating statements that have ands and ors in them. That's what they are, okay? So I'm going to write you the forms for De Morgan's Laws. So this is a negation. If I'm negating a statement that is P and Q, it's kind of like in algebra when you put a negative in front of something with parentheses, right? You have to do this thing where you distribute the negative over the parentheses. Do you guys remember that from algebra? Same kind of thing here. We're going to take the negation symbol and we're going to distribute it over the parentheses. So my P is going to become tilde, and my Q is going to become tilde Q. But there's one other thing that happens. So you notice that and symbol? It gets negated as well. So what do you think happens when you negate an and?
Or.
It becomes an or. That's right. So we've got this. And we've got a similar De Morgan's Law for an or statement. So if I have tilde P or Q, so let me take a stab in the dark. What's that going to look like?
Tilde P and tilde Q.
Tilde P and tilde Q. Now, with language, it's even easier, okay? You just change every piece of it once at a time. So there's 3 pieces here. There's 2 statements. One statement says, it is summer. One statement says, there is no snow. And then we've got the conjunction and in the middle, okay? So what is the opposite of it is summer? What is the negation of it is summer?
It is not summer.
It is not summer. Don't tell me it's winter, right? That's not the negation because we've got other seasons. So we would say it is not summer. We've got this and in the middle. What's the negation of and? Or. And we've got the statement at the end that says there is no snow. There is snow. Easy, easy, right?
Yes.
That's how you negate it. You negate each piece individually, and you negate the conjunction or the connective in the middle. All right.